When we picture artificial intelligence, we often imagine invisible software, voice assistants, movie recommendations, digital ghosts in our devices. These AI tools feel weightless, almost magical, seamlessly woven into our daily routines. We ask questions, get directions, or receive personalized suggestions, all without ever seeing the machinery behind the curtain. But every AI thought has a physical home, massive data centers. Picture a warehouse the size of several football fields, filled with endless rows of powerful servers, all connected by a web of cables. These facilities are the beating heart of the digital world, quietly working day and night to process unimaginable amounts of information. This is where your data lives, where AI models learn, and where your digital life is processed. Without these concrete, steel, and silicon structures, AI would not exist. Teams of engineers and technicians maintain these centers, ensuring that every server is running smoothly and securely, so your digital experiences remain seamless. Data centers are connected by vast networks of fiber optic cables, forming the backbone of our digital world. Every AI request you make travels through this network, gets processed in these centers, and returns to you in milliseconds. These connections span continents, linking cities and countries, making global communication and instant access possible. The scale is staggering. A single data center can house hundreds of thousands of servers, generating immense processing power and heat. Keeping these machines running and cool requires enormous amounts of electricity. Specialized cooling systems, backup generators, and advanced monitoring are all essential to keep the digital world online. Data centers are evolving into digital power plants, central to how we manage and distribute energy in society. The invisible world of AI is built on very real, very physical foundations. As our reliance on AI grows, so does the importance of these technological fortresses, shaping the future of our connected world. Next time you use AI, remember, it's powered by hidden technological giants humming away somewhere in the world, tirelessly working to bring intelligence to your fingertips. Our digital lives are expanding at an unprecedented pace: streaming, gaming, cloud storage, and now, the explosive growth of AI, all driving up demand for data center power like never before. Every new app, every online service, and every connected device adds to this invisible but ever-growing energy footprint. Every online action, no matter how small, taps into a data center somewhere in the world. Billions of people doing this daily, sending messages, uploading photos, searching the web, adds up fast, creating a tidal wave of digital activity that never truly sleeps. Training large AI models is especially energy-hungry, sometimes using as much electricity as hundreds of homes in a year. These powerful computers run day and night, crunching vast amounts of data to make AI smarter and more capable. Even after training, every AI query, called inference, requires power. With billions of users asking questions, generating images, or using AI assistants, the demand for electricity never stops, and the cycle continues around the clock. As AI becomes more capable and accessible, we use it more in our daily lives, fueling a cycle of ever-increasing energy needs. From smart recommendations to real-time translations, AI is woven into the fabric of our routines. The Internet of Things adds to this, with billions of smart devices, everything from thermostats to fitness trackers, constantly sending data to data centers, further increasing the load. From streaming movies with family to tracking your morning run, every digital moment feeds this insatiable appetite for power. Even the smallest interactions like checking the weather or syncing your watch contribute to the demand. Data centers have become some of the world's hungriest energy consumers, rivaling entire cities in their electricity use. The more we rely on digital services, the more power these hidden factories require. Behind every click, stream, or AI response, there's a vast infrastructure working tirelessly to keep us connected. Our digital convenience comes with a massive growing energy bill, one that's often out of sight, but impossible to ignore as our dependence grows. The future of AI is inseparable from the future of energy. As we push the boundaries of what's possible, the challenge will be finding ways to power our digital world sustainably. Building a data center used to be about network speed and cheap land. Now, it's all about electricity. The biggest question: where can we get enough power? A single data center can use as much electricity as a small city, forcing utilities to rethink their entire grid. Data centers are now as important in energy planning as power plants. Regions must factor in the digital economy's needs alongside homes and factories. Reliable, abundant, and clean energy now determines where digital infrastructure can grow. Data centers and power plants are two sides of the same coin. One produces, the other consumes at industrial scale. The future of digital growth is tied directly to energy strategy. Where there's power, there's potential for AI and cloud computing. Thousands of tightly packed computers generate intense heat. Cooling them is a massive challenge. The more powerful the servers, the more heat they produce, and the harder it becomes to keep everything running smoothly. Without proper cooling, equipment can overheat, slow down, or even fail, risking costly downtime. Up to 40% of a data center's energy bill goes to cooling, not computing. That means nearly half the electricity used isn't for processing data, but simply for keeping machines at safe temperatures. This makes cooling one of the biggest expenses and environmental concerns for data centers worldwide. That's why companies seek out cool climates, places like Iceland or the Pacific Northwest, to use outside air for free cooling. Harnessing naturally cold air can dramatically cut costs and reduce the carbon footprint, making these regions especially attractive for new facilities. Water is also crucial. Many centers use evaporative cooling, which can consume millions of gallons daily. This process uses water to absorb heat and carry it away, but it puts pressure on local water supplies, especially in areas already facing shortages. In dry regions, this creates tough choices about water use. Communities must weigh the needs of technology against agriculture, drinking water, and the environment, sparking debates about sustainability and resource management. The ideal data center site balances cheap land, abundant electricity, cool weather, reliable water, and access to fiber networks. Each factor is critical, and missing just one can make a location unworkable for large-scale computing. Natural disasters and environmental risks add to the puzzle. Floods, wildfires, and storms can threaten operations, so companies must plan for resilience and backup systems. That's why data centers cluster in regions with the right mix of resources. These hubs become magnets for investment, talent, and innovation, shaping the digital landscape. The digital world's geography is shaped by old-fashioned physical needs. Where we build the internet depends on water, weather, and the land beneath our feet. Every AI breakthrough depends on solving these real-world challenges, reminding us that even the cloud is grounded in reality. Data centers have sparked a global energy race. Tech giants now compete for reliable electricity as fiercely as for software talent. Companies invest billions based on a region's energy profile, seeking stable grids and predictable prices. Local governments and utilities court tech firms, offering power to attract data center projects. Tech companies are funding new wind and solar farms, sometimes even building their own power plants. This gives them control, helps meet sustainability goals, and shields them from price swings. But the competition strains local grids, sometimes forcing tough choices between powering data centers or communities. Reliable power is now a finite strategic resource. The outcome of this race will shape which regions thrive in the digital age. A new data center can bring jobs, tax revenue, and investment to a community. Construction creates hundreds of jobs. Operations need skilled technicians and engineers, but these facilities also consume huge amounts of electricity and water, straining local resources. Residents may worry about higher bills, water shortages, or the impact of large windowless buildings on their neighborhoods. noise from cooling systems, and changes to local character are common concerns. Communities must weigh economic benefits against environmental and quality of life costs. Every data center project shapes the future of its town for decades. Data centers power the digital world, but their environmental impact is massive. Digital services can reduce emissions, think remote work or streaming instead of shipping DVDs, but the electricity data centers use, especially from fossil fuels, drives up carbon emissions. The tech sector's carbon footprint rivals the airline industry and is growing fast. Tech giants are investing billions in renewables, aiming for 100% clean energy. Yet wind and solar are intermittent, so data centers still rely on fossil-fueled grids for reliability. Water use for cooling and e-waste from short-lived hardware add to the environmental toll. Building sustainable data centers is one of this century's biggest challenges. The digital revolution's green future depends on solving these issues. We dream of AI solving humanity's biggest problems, but its future is built on physical infrastructure. The speed of AI progress depends on how many servers, chips, and data centers we can build and power. More capable AI means more land, water, and, above all, electricity. The next wave of AI innovation is as much about engineering and resource management as computer science. Countries with abundant clean energy will become new AI hubs. The race for smarter AI is also a race for better, more efficient data centers. The digital world's limits are set by real-world resources. The future of AI is grounded in concrete, steel, and electricity. Data centers aren't just a tech issue, they affect us all. Their energy use shapes electricity prices and drives decisions about new power plants and grids. Their water and energy needs impact local environments and climate. As citizens, we can push for renewable energy and smarter digital choices. Data centers bring jobs and investment, but also challenges for communities. Public engagement ensures these facilities benefit everyone, not just tech giants. Our digital lives are built on this infrastructure. We all have a stake in the future of data centers,